السلام عليكم. معكم أخوكم عيسى، وفي هذا الفيديو I will explain problem 1610 from Dynamics in page 332. So in this equation, in this question, it says at the instant omega A equal 5 rad per second, pulley A is given a constant angular acceleration alpha A is equal to 6 rad per second square. So when you see this one, constant angular acceleration, you should look at omega square equal omega initial square plus 2 alpha times theta minus theta theta naught. Okay, so let's continue. Determine the magnitude of acceleration at point B. So we need to find AB. AB is equal to what? When on pulley C, when A rotates 2 revolutions. Okay, pulley C has an inner hub which is fixed to its outer one and turns with it. Okay, let's see what we have. Let's convert first the radius. RA is equal to 0.0 is equal to 0. RA is equal to 0. Sorry, RA is equal to 0.05 meter. Okay, RB is equal to 0.06 meter, and RC is equal to 0.04 meter. Okay, so we know also theta A is equal to 2 revolutions times 2 pi per revolution. So revolution will go. We will have 2 times 2 pi, 12.566 rad. So after finding theta, let's use this equation, omega final. Okay, so we'll say omega A square equal omega naught A square plus 2 alpha A times theta A minus theta naught A. Okay, so theta A we already know. We know omega naught, yeah, we know omega A naught A is equal to 5 rad per second, and we know also alpha A is equal to alpha A is equal to 6 rad per second square. Okay, so let's put these numbers here. So omega A square is equal to uh, omega a naught, which is 5 square, so it will be 5 square plus 2 alpha a, 2 times 6 times 12.566 minus 0. So omega a square will be 175.792. Omega a will be 13.258. I just took the square root of both sides. Don't forget the unit, it's rad per second. Okay, so we got omega a. Now we can find omega c. How? Because omega a is connected to omega c, right? This is omega a is connected to omega c. Same rotation, same. They are connected together, these two circles. So we can say omega a RA equal omega c RC. Omega c RC. Okay, so omega a is we just get it as 13.258 times RA, which is 0.05. It's equal to omega c times RC. RC was 0.04. So omega c will be, with simple calculations, 16.5725. Okay, so this is omega c, rad per second. Don't forget the unit. We got omega c, and because omega c, because c is inside b, this is c is inside b, right? So this is c and this is b. There are two circles inside each other, so omega c will equal to omega b. Omega c equal omega b. They must be equal. So omega c is equal to omega b is equal to 16.5 0.5725 rad per second. Now let's find alpha c. It's the same. Alpha a RA equal alpha c RC. Why? Because they are connected to each other. So alpha a was 6, RA is 0.05 equal alpha c, which we don't know, times RC, which is 0.04. With simple calculation, our alpha c will be 7.5. Rad per second square. And again, because c is inside b, so alpha c equal alpha b equal to 7.5 rad per second square. Okay, now we know alpha b, we know omega b. Let's find A tangential at b. It's equal to alpha. Okay, A tangential at b is equal to alpha b rb. It's equal to 7.5 times rb, which is 0.06. It should give you 0.45 rad per okay, 0.06 equal 0.45 rad per second square. Okay, rad per second square. So now we got A tangential. We need to know the A normal at B. A normal at B is equal to omega B square times RB. Omega B square times RB. Okay, so A normal at B is equal to 16.5725 square times 0.06. So A normal at B will give you 16.4789 meter per second square. So A is equal, AB is equal to A normal at B square plus A tangential at B square. So AB is equal to square root of 16.4789 square plus 0.45 square. We got A normal as A tangential as 0.45. Yes. Okay, so AB will give you 16.485 meter per second square. Okay, so we got AB. Now we have to find VB. VB is easy, it's just equal omega B RB. VB is equal to 16.5725 times 0.06. So on VB will give you VB will give you 0.994 meter per second. And we found VB, so we found VB and we found also AB. Okay, so we have solved the problem. Thank you for watching the video.